Hey, so today we are talking about molar mass. Now, molar mass may seem like a new topic, but it actually relates a lot to things we've already talked about relative to the periodic table and moles. So, molar mass is defined as the mass of a molecule or element as measured in grams per mole. So, you could include here the mass of a molecule or element as measured in grams per mole. Now, if we're calculating the molar mass for just an element, it's really convenient. We've talked about this down here. This is the mass number. If you look on your periodic table, found down at the bottom of each element. This is the mass number. We've talked about it plenty of times. The mass number is the molar mass of that given element. So for oxygen, if I were to ask you, what is the molar mass of oxygen? You would respond 15.99 grams per mole. So if we were given 1 mole of oxygen, its mass would be 15.99 grams because we're measuring it in grams per mole. If I gave you a mole of carbon atoms, here is a mole of carbon atoms. Here is 6.02 times 10 to the 23rd carbon atoms. Its mass would be 12.01 grams. So if you had a bunch of carbon and it measured out at 12.01 grams, you would know that was exactly 1 mole of carbon. So with elements, it's quite simple. The mass number is equal to the molar mass for elements. And let me type that out so you have that. So the mass number of a given element is equal to the molar mass of that element. Now remember, molar mass, you have to have a mole of that element. So if we had half a mole of oxygen, its mass would be about 8 grams if we had half a mole, because we need a whole mole of oxygen for its mass to be 16 grams. So I want to do a few examples with you, because if we get to compounds and things like that, you have to calculate a variety of things. So that is our molar mass. We've done oxygen. The molar mass of oxygen is 15.99 grams. You can round that to 16, that's okay. And the molar mass of carbon is 12 grams. So make sure you have your periodic table out, or you can look at the periodic table up in the corner. And if I were to ask you, what is the molar mass of nitrogen? Well, what you would do is you would look at your periodic table. You come up here, and you would find nitrogen. Now, if you zoom into nitrogen on here, and you were able to look at nitrogen there, then if you're able to look at nitrogen right here, you would see that its mass down here at the bottom is 14.007 grams. Therefore, the molar mass of nitrogen is 14.007 grams. It's just the same as the mass number. The mass number, remember, of a given element is equal to the molar mass of that element. So for nitrogen, the molar mass of nitrogen, if we were doing some example problems, nitrogen's molar mass would be 14.007 grams per mole. So what if I suddenly said we have half a mole of nitrogen? How in the world are you going to figure that out? Well, if it's about 14 grams for 1 mole of nitrogen, half a mole of nitrogen would be about 7 grams. Because if 1 whole mole is 14 grams, half a mole is going to be about 7 grams. So individual elements, really simple. It's just the same as the mass number. Now when we get into compounds, that's when it gets a little more complex. So say we're dealing with water, which is H2O. H2O is water, and I want to know the molar mass. Well, shoot, how are we going to figure that out? Luckily, we have our handy-dandy periodic table right here, and you do it kind of with the same process. So we have hydrogen, we have 1 hydrogen. Oh wait, no, it's H2. We have 2 hydrogens, and we have 1 oxygen. So the process you're going to go through is you find the molar mass of each individual element, and then you add them together to get the molar mass of the entire compound of water. Now you see I put 2 H's here. I put 2 H's because we have 2 H's in water. So to calculate the molar mass of water, I need to make sure I include calculations for 2 H's and 1 oxygen. So I go back to my periodic table, and I look at an H and see it's 1.0074. I can just round that to 1. So each one of my hydrogens, its mass is 1 gram. So 1 gram for that one and 1 gram for this one. Now let's take a look at oxygen. Oxygen Luckily, we have a zoomed in version of it right here. It's 15.99. We're going to go ahead and round that up to 16. So oxygen's molar mass is 16 grams. So now, all we have to do to calculate the overall molar mass for the entire compound of water is add 1 plus 1 plus 16. So H2O, its molar mass is 18 grams per mole. So if we had 1 mole of water, you have 18 grams of water. So that is molar mass. Now let's do another compound. Let's do NaCl. So how in the world are we going to solve? I want to know the molar mass. How in the world are we going to solve the molar mass of NaCl? Interesting. Well, we separate it into its composite elements, right? So we have Na and we have Cl. Then we just go look at their mass numbers on the periodic table and we'll add them together. So Na, you have right here, it's going to be about 22.99, so we're going to round that to 23 just for simplicity's sake. You can always round like that, so it's going to be 23 grams. And then you're going to go to chlorine, which I'll look up on my board. It is, you'd find it right here, and it's about 35.4, so we're going to round that down to just 35. So 35 grams, 35 grams. Then we just have one of each, right? So you just add those together. 35 plus 23, you're going to end up with 58 grams per mole is the molar mass of NaCl. Everybody see how we got that? We're just separating the compound into its composite elements and then adding their different mass numbers together. We're going to do another example with 3. If I gave you NaOH, try to solve this one on your own. Real quick, pause it, try to solve it on your own. Okay, hopefully you paused it. We have Na, separate it into its composite parts first. Na, O, and H. You're separating these all out. Na, O, and H. Na, again, we look at our periodic table, is 23 grams. O is 16 grams, and H is 1 gram. You add those together, NaOH, molar mass, equals about 40 grams per mole. So if I gave you 1 mole of sodium hydroxide, its mass would be 40 grams. Excellent. Okay, 2 more examples. Just getting more and more complex. This time, if we had Na3, sorry, I can't do subscripts on here. Na3 and then PO4. Got to separate it out first. So we have Na, Na, and Na. Why did I do 3 Nas? Because I have 3 Nas in my formula right here. And then we have 1 P, right? Because this 4 only applies to the oxygen. So we have 1 P, and then we have 4 O's. Whoops. 3. There we go. Victory. 4. It's going to be a lot of math. So we have Na is 23 grams. 23 grams. 23 grams. Phosphorus. Let's look up at phosphorus. Phosphorus is about 31 grams. And then oxygen, we have 16, 16, 16, and 16. So you just add those all together and get 46, 69, 100, 132, 164. Let's hope that math is right. But you just add these all together. You end up with 164 grams per mole is the molar mass of Na3 parentheses PO4. So right there, 164 grams per mole would be the molar mass of sodium phosphate. So really, all you're doing is separating these out into their composite parts. Now, I'm going to show you a quicker way to do this with this problem, and this is actually going to be our last example, the quicker way to do this. So you see how I typed all this out, Na, 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 P, and then O, 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 O. Another way you can do this once you get the hang of it is if you know you have 3 Nas, you can just put Na, and then you know its molar mass is 23. You can just do 23 times 3. And then for P, you just have 1, so it would just be 31. And then for O, you could do 16 times 4. And then you can do a little less addition because then you can know right away this is 69, this is 64. And then you can just add 69 plus 31 plus 64, and you can get your answer. So that's molar mass. What I want you to do, you have practice problems that are just molar mass. Don't go on to unit conversions using molar mass. Just do the problems calculating molar mass, and then show me those examples when you finish, and I will give you approval to move on. Good luck and farewell.